This would be less than 99 if you keep this short at home. Variation. Probably to understand inverse variation better, you probably should think most of the things we talk about are usually direct variation. And if you go back in your notes, we talked direct variation. Direct variation basically, let's like put a little side note over here. Direct variation basically is on the premise that as one goes up, the other goes up. As one goes up, so does the other. And I believe if you look back, probably the example I gave you is if you've got a job, your pay is in direct variation with the hours you work. In other words, if you've got a job, and at your job, you make $8 an hour. If I were making a table of your pay, that is going to be direct variation because, let's make X the number of hours you work. If you work 1 hour, you're going to make $8. If you work 2 hours, you're going to make 16. If you work no hours, you're going to get 0 money. If you work 5 hours, you're going to get $40. As the hours you work, the more hours you work, the more your pay is. And it's proportional. Okay? And we set up this little thing here that said this. Y, the little formula is Y equals KX, where K is what's called your constant of variation. That was our direct variation thing. I multiply whatever X is by 8 and I get Y. Okay, when you graph it, it goes through the origin, it's a straight line. Now, if that's direct variation, guess what indirect or inverse variation is? It's this. It is, yes, as one goes up, comma, the other goes down. Now, an example of that might be,
miles and minutes.
Huh?
No,
Well, it is,
like time.
yeah.
That's
If
what
you're
I was
doing your speed, how fast you're going, and the distance. No.
Time.
And the time it takes you. Speed and time. Right? So let's say Y. Well, we have to wait. The inverse variation instead of this is, let me make sure I get it right because I sometimes flip those over, is inverse variation is X times Y equals K. Okay, X times Y equals K. And that could be, this could be speed and time. And distance equals there. For example, let me grab one out of the book here. Rate times time equals 120. Yes. You know, let's say you're going from here to Morris. And from here to Morris is 20 miles, right? So here would be the X and Y thing. If X is your time and Y is your speed, okay? If you are, well, let's do yours. Maybe we should make them the other way around. If you're going 10 miles an hour, we should probably do that the other way around. Let me do that the other way around. Can I change that? Yes, I can. I'm the teacher. X equals speed and Y equals time. I've got to get rid of this. How do I get rid of that?
Oh, that's a big one.
Oh, it's unusual.
Oh, so big.
Can you just pick the 10?
I could, but I think I'm going to erase. So here's the deal with this. So let's say your speed is 10 How long is it going to take you to get to Morris? 2 hours, because it's 20 miles. All right. As you go faster, if your speed is 20 miles an hour, how long is it going to take you to get to Morris? Only 1 hour. As your speed goes up, here, if you're going 40 miles an hour, how long does it take you to get to Morris?
Half an hour.
Half an hour. If you're going 80 miles an hour, how long is it going to take you to go?
15 minutes.
A quarter of an hour. Now, the beauty of inverse variation is this. This is the easiest way to do this. X and Y always have to equal the same thing. In other words, 2 times 10 is 20. This times this is 20. This times this is 20. This times this is 20. Another example of that might be if you're doing a job with help from your friends. Okay? Check this out. If it takes one person 8 hours to mow the lawn, well, let's say he gets a friend, 2 people would take how long?
4.
Remembering that when you multiply these together, everything now has to equal 8. Because it's going to take, it takes 8 hours no matter how many people you have, you just have to split it up equally among them. 2 people, it would be 4 hours. 4 people, it would be 2 hours. If you had 8 people, it would only take 1 hour to do. If you had 16 people, it would take a half an hour. If you had 32 people, it would take a fourth of an hour. Is that right?
Yeah.
If you had 64 people, it would take an eighth of an hour. Now, I think we went through this again. The deal is, let me show you this. If we graph this, here's the graph. Let me make that chart again. Let me make that layer chart again, X and Y. And this was, the constant of proportionality there, by the way, was 20. And our little equation is X times Y equals 20. Or, if you want to do it in Y, Y equals 20 divided by X. That actually is the same thing. Let's do this. It was 8, 1 was 8, right? 1 person 8, 2 person 4, 4 person 2, 8 people 1, 16 people half, 32 people a quarter, 64 people 1/8. If you graph that, look what this looks like. 0 people, by the way, would take how long?
0.
No, that would be
Infinite.
Let's look at this. 1 person,
Oh, that's not possible.
1, 2, 3, 4, 5, 6, 7, 8. 1 person would take 8. 2 people takes 1, 2, 1, 2, 3, 4. 4 people took 2 hours. 8 people, 5, 6, 7, 8 took 1 hour. 16 people took a half an hour. 8, 9, 10, 11, 12, 13, 14, 15, 16. Here is the graph of inverse variation. And the deal with that is you can never ever get to 0 here for time. You could never have so many people that it would take you 0 hours because there's no way the job could get done. And the same thing is here. You could never have, what is this line here? Yeah, what were these? This was my X was how many people. You could never have however many people that would give you 0 on this line here. So you will always approach, we call that limits, I believe, in the upper level math. This will never cross the y-axis or x-axis, and this will never cross the y-axis. It will get incredibly close, like if you had 1,000,000 people. How long would it take you? It would take this, 20 over 1,000,000 amount of time, which would be 2 over 100,000, which would be 1 over, it would take you 1 over 50,000 of an hour. Could you do that in minutes? It would be in what? Less than a second. How many seconds are in an hour? 60 times 60,
Yeah.
360. Wait, 360? 60 times 3600. So blah, blah, blah. It would take you about half of a second or a quarter of a second, maybe, to do the job if all of them were working. You had a million people there. But you'll never get
They only have 2
to
mowers.
those limits. So, let's put that, let us put that into relation to what was the question they asked you that we didn't know how to answer? 24, if the volume of air in a balloon is inversely proportional to the pressure, if the volume increases as the balloon rises, what happens to the pressure? Well, they didn't tell you, but it decreases. See, you need to find a problem where that you actually have a problem. All right, look at. Well, let's go back to page 661. Just so we have a problem that we can do. Look at letter G. Just so you know how to do inversely proportional problems. If the volume of air in a balloon and the air pressure in the balloon are inversely proportional, if the balloon is squeezed to half of its original volume, by what factor does the air pressure increase? Okay, so basically they're saying this, you know that x times y equals some constant, right? That's what our inverse proportional thing. What two things are we talking about? We were talking about volume and air pressure. So volume times pressure have to equal a constant. And it says this, and you can pick anything there. If the balloon is squeezed to half its original volume. So here, they don't tell you what the original volume is, right? But you can make it up. Let's do our x and y. Well, this would be v and t. Because of that, you can pick anything you want for either one of those, because they didn't tell you what it is, right? They just said it's inversely proportional. So give me something. Volume would be
10,
all right, pressure would be
2.
2. So that means your constant is 20, right?
Yes.
Now, what do they tell you happens? It said that the volume was squeezed to half. So what is half of this?
5.
So what would this have to be?
4.
So what happened to the pressure? It went from 2 to 4, so what happened?
It raised
By
double the
much?
time.
Yeah, double, times 2. And that's what the actual answer for that is. It says, by what factor did the pressure go up? Times 2. Which would mean it just have to be the 1. So just get that in here. So that right there would raise your map score by a point. I don't know if I have enough of this in here. Alright. Let me stop this, because then now take out a blank piece of paper.